Welcome back everyone to this discussion where we're talking about why machine learning. Why do we use machine learning? What is it useful for? And what is machine learning? There's a lot of questions that we haven't answered yet of why we actually go through all this effort to learn about and implement machine learning when we've actually already learned so many skills in data analysis so far. What is it that machine learning allows us to do? Let's start off with a definition of machine learning. Machine learning, in general, is the study of statistical computer algorithms that improve automatically through data. So there's a really key sentiment there that we need to understand. Because the computer algorithms are improving automatically through the use of data, this means that unlike typical computer algorithms that are going to rely on human input for what approach to take, the machine learning algorithms in general are going to infer the best approach from the data itself. So machine learning is a subset of artificial intelligence, and machine learning algorithms are not explicitly programmed on which decisions to make. Instead, that algorithm is designed to infer from the data the most optimal choices to make. So what kinds of problems can machine learning solve? Machine learning can solve many different types of problems. And here's just a very brief example of the different types of problems we can solve. We can do things like credit scoring. Essentially, if we're running a bank, we want to know whether or not someone is creditworthy, and if we want to offer them something like a mortgage or a credit card, and how much should their limit be on a credit card. What we can do is use data on that person's history to decide what is an acceptable credit limit or whether or not we want to give them a mortgage. Then there's also things like insurance risk, which is very related to what we just talked about with credit scoring, where we essentially have to determine what is the risk that we're taking on and what should we charge someone for an insurance premium and what do we expect to pay out over the lifetime of this insurance policy. Then there's also things like price forecasting. We can use historical data on houses that have sold in a neighborhood to try to predict what a new house on the market would sell for. There's also things that we maybe don't think of as machine learning, but actually are. Things like email spam filtering. Email spam used to be a huge problem that luckily now machine learning has pretty much solved. It's very rare now to get so much spam in your normal inbox. Instead, a lot of it's now going to that spam folder, and it really kind of decimated a spam industry because of how effective machine learning has become in this field. Then there's also things like customer segmentation. Many corporations and marketing agencies have large swaths of customer data that they then want the machine learning algorithms to automatically segment and cluster based off the various features in the data. And this is just a very small sampling of the many types of problems that we're going to be discovering throughout the course that machine learning can solve. So, since it can cover so many different types of problems, how does the structure of a machine problem actually work in its framing? So in general, what a machine learning problem does is you have a data set, and given features from that data set, you want to obtain a desired label. So the main words here are features and label. So overall, for all the machine learning problems that we're going to be discovering along the way for this course, we're going to see that the data has features, and we either want to predict a future label or we want to try to assign a label. And machine learning algorithms are often called estimators, since at the end of the day, really they're just estimating the desired label or output. So, how can machine learning be so robust in solving all these various types of problems? Well, machine learning algorithms rely on a data set and a set of statistical methods to learn what features are important in the data. It doesn't require a human user to tell the computer algorithm what to look out for. Instead, many of these machine learning algorithms, relying on a set of statistical methods, are going to automatically infer what features are important in order to either predict a label or assign a label. So let's think of a very simple example, and this is an example we're going to come back to a lot because it's something we already know and see in the real world, and it's something that's really common, especially for regression tasks when you're first learning about machine learning. So the simplest example for where we could apply machine learning that we can think of here is probably something like predict the price of a house should sell at given its current features. So, for example, we have a house that we want to put on the market to sell. What price should we actually say that this house is for sale at? And we know the area of the house in square feet or in meters squared. We know how many bedrooms it has, the bathrooms, what kind of carpeting it has, etc. We know all these data features of the house. And now what we want to do is predict the label, where the label is going to be the price we list and sell the house at. So obviously we have human realtors that are doing this, and in a sense these human realtors before machine learning were kind of doing what a machine learning algorithm does. They take in all these features inside of their head, and then based off what they know about historical houses that have sold, then they're going to try to come up with a reasonable price to sell this new house at. So a typical computer algorithm would be where a human user defines an algorithm manually to set values of importance for each feature. So typically before machine learning, if you wanted to try to use a computer for this, you still have to have a human define all these sets of values and have distinguishing features of, say, oh, number of bedrooms is more important than number of bathrooms, or at this many bedrooms, set it at this price, or at this square footage, set it at this price. And so you'd have to have a very detailed and complex algorithm all defined by humans for set values for each feature. Now luckily, we can actually improve on this through the use of machine learning algorithms, where a machine learning algorithm will automatically determine the importance of each feature and how they are related to each other just from the existing data. This way, a human no longer has to manually assign the importance of each feature in the dataset in order to predict a label. The machine learning algorithm is going to use statistical methods, which we're going to learn about throughout the course, on determining the importance of each feature in order to predict the label. So, why do we actually use machine learning in general? Well, many complex problems are actually only solvable with machine learning techniques. Problems such as spam email or even things that are more complex, like identifying handwriting, require machine learning for an effective solution. In fact, machine learning is present throughout our lives if you're using any sort of modern technology. So for instance, if you were to write on a letter someone's address and then send it in the mail, it's highly likely that a machine learning algorithm is actually reading an image of your mail in order to determine the address of where it should go. No longer do we have humans having to read every single package of mail, especially if it's being handwritten. So machine learning has gotten so good it can actually then read in your handwritten digits. So then comes the next question. If machine learning is so great, why don't we just use it for everything? Why bother with any human-defined algorithms? So the major caveat to being able to use machine learning is that we need good data. Recall that machine learning is actually discovering things based off existing data, and we already know that it takes a lot of work to clean and organize data, which means the majority of development time from a human perspective is actually spent on cleaning and organizing data effectively for a machine learning algorithm. Your development time is actually not spent that much on implementing or calling a machine learning algorithm. Ironically, that's usually the easiest part of the entire process due to the fact that many machine learning algorithms are well known, well documented, and they're already defined in existing Python libraries, which means you don't actually have to do any work when calling a machine learning algorithm. Instead, most of your time is going to be on developing a good data set for that machine learning algorithm. So that's why we can't just use machine learning on every single problem, because we require the appropriate data in order to apply a machine learning algorithm effectively. So another question then arises is, why not we just develop our own machine learning algorithms? Well, in general, it's really rare to have that need to manually develop and implement a new machine learning algorithm, since, as I mentioned, these techniques are well documented and well developed. So instead, we leverage the work that's already been done on things like the scikit-learn library for Python. So we won't actually have to manually code out or develop our own machine learning algorithms. However, we will need to have an intuition and understanding of how the algorithms work before we just call and import them from scikit-learn in Python. So let's go ahead and continue this discussion in the next lecture by exploring the different types of machine learning algorithms, specifically the differences between supervised learning and unsupervised learning. I'll see you at the next lecture.